Hello everyone, my name is Donnie Prakoso. I'm a technical evangelist working with Amazon Web Services based in Singapore. And we are so glad to have you joining us today for AWS Innovate Online Conference Machine Learning and AI Edition. This session is intended for you, developers, and to help you understand how to orchestrate operational workflows using AWS step functions, identify a few common workflow patterns, and also integration with various AWS machine learning services, including Amazon SageMaker. I also have few comprehensive demos, so stay tuned. Before we start, let's discuss the agenda we'll cover for today to give you a big picture in understanding this session. First, we're going to discuss operational workflow and its place in our system. Moving on to the next agenda is exploring a few workflow patterns taken from various cases of our customers applying AWS services as a central integration of their workflows. Now, after having a good understanding both on the workflow and its patterns, we're moving into the main part of this session. In this section, we will learn together how to utilize AWS step functions and few patterns that we have learned before to build a fully resilient end-to-end machine learning pipelines with serverless approach. So let's get started. Let's talk about workflow. Every company and developer have a need to automate the process to achieve a specific objective. A workflow consists of a repeatable and reusable independent microservices that serve business activities that require integration of various services and done systematically. There are many use cases involving workflow. To name a few, which we are going to use as the base of our demo, is podcast transcription workflow. First, we need to fetch the audio, and then add custom vocabulary, and finally do the transcribing process. Another example is coming from a media and entertainment company. They need a workflow to automatically tag any media uploaded. This media content can be uploaded by them internally, or if it's a UGC-based platform, it should tag any media uploaded by their users. From there, it needs to build an index in order to query based on specific keyword. We often rely on these workflows in order to make our system work properly. But the biggest challenge is on the orchestration of the workflow itself. It needs to run properly over time. All of those operational workflows will be challenging if it's done manually. So we need to have a better approach to orchestrate this workflow process. If you are in this situation who need a reliable and powerful orchestration service for your workflow, I'm delighted to introduce you to AWS Step Function. With AWS Step Functions, you can design, visualize, and run workflows that integrate various services with higher resilience. Because its nature that can combine one service to another, it makes you more productive as you can spend more time thinking about innovating the business logic, and your applications are easier to operate and maintain. AWS Step Functions records a history of each execution, making it easier for you to review in one place all the events in a sequence in one location. AWS Step Functions make it easy for us to build workflow and integrate microservices into feature-rich system. And there are a few patterns in implementing workflow that I love to share with all of you. First, as workflow involves many parts, it can be built using the microservices approach. It can be polyglot in terms of component or even its functionalities. Then, we need to monitor asynchronous processing because not everything can be done in synchronous way. Looking at few stages that we might have, we also need to have availabilities of all data at each stage. And lastly, we can also abstract a child workflow and be as part of larger workflow. So let's start with the first pattern, polyglot operational workflows. For both analytics and machine learning workflow, you might encounter something similar like these two workflows. In machine learning workflow, we need to first ingest the data first, then prepare the data to be processed, continued by training the model, and the last part is doing inference through an endpoint and also tuning. In analytics workflow, we need to extract the data, transform it to suit our needs, then load and do the query. As you can see, workflow consists of few parts, and it is highly encouraged to decouple these components in order to make it easier to scale and manage. Let's dive deeper and see how we can actually transform our code to workflows. Here is a simplified code that we can use to transcribe podcast RSS. First, we need to ingest the data by getting the feed from a specific URL. Then we need to tune it a little bit by creating a custom vocabulary to have a smooth transcription. The last step in this code is to infer by calling transcribe function for specific episodes with given vocabulary. As you can see, it looks pretty similar with machine learning workflow that we've seen in the previous slide. On the right side, you can see a few factors that we need to implement so we can have a resilient system. To have concurrency control, I've added a function await so it won't block the entire flow. Also, we need to have an error handling. This is to catch if anything fails, we have anticipated it. But unlike traditional try-catch, we need to have retry function to reprocess those functions that failed previously. Each podcast consists of multiple episodes. Now, at this stage, each episode needs to be processed. However, each episode needs to have its own state. Our workflow needs to have good state management so the operation at the specific stage can run properly. So let's see how we can orchestrate this specific workflow with AWS step functions. This is a high-level architecture for the demo that we've prepared. Next demo is for transcribing podcasts using microservices approach and integration with AWS step functions. We're going to use AWS step functions to coordinate workflow to get podcasts, do the transcription, and feeding it into Elasticsearch. In this demo, we will show you how to use AWS step functions by combining several microservices to transcribe a podcast from an RSS URL. This is my AWS step function dashboard. As you can see, I already have a few state machines built for this demo. RSS state machine is the main state machine to fetch and also create custom vocabulary using Amazon Transcribe. Inside podcast RSS URL, we have multiple episodes. And the other state machine called episode state machine is a state machine that processes these episodes and ingests the data into Elasticsearch so we can perform my query. Let's start with RSS state machine. This is the detail page for each state machines in AWS step functions. On the box below, you will see that we have 3 tabs. Execution tab shows us a list of history of running and previously executed state machines. In this tab, you can see that I run a few executions along with details on status, time started, and where it was ended. If you're looking for the history of your executions, you can go to this tab and review those executions. Definition tab has the language definition using Amazon state language to describe state machines declaratively. Inside this tab, it also has a nice visual representation of your state machine definition. It gives us clarity of our workflow, and if you want to make changes, simply click on the edit button and save it afterward. Let's go back to the execution tab. Let us review together one execution that has completed so it will give us a big picture on how everything goes. This is the execution details page. You can see every event that has been triggered and executed both for failed and succeeded in this tab. We also have details for each step to give you a granular level for reviewing your state machines. Here you can see that we have details on process podcast RSS function. As you might already have noticed, all of these functions besides Elasticsearch in this state machine are being executed by AWS Lambda. This Lambda function is written in Python 2.7. It's normal Python code. So let's go back to step function page. I'm interested in what kind of input we supply in order for this state machine to run. This is the input that we supply to the state machine. We have RSS URL, which is hosted by CloudFront. In reality, this URL can be anywhere as long as it's publicly accessible. Then we define how many episodes we want to process. We also have optional configuration dry run for debugging purposes. Moving on to the output. Inside the key value variable of episodes, we have information regarding the location of S3 storage, which we use to hold the data. We have bucket key and also the path location. At this stage, we already have our first data, which is the episode list of the podcast itself. On the visual workflow diagram, we can see the workflow this state machine performs. Now let me guide you for each state in this workflow one by one. The initial step is processing podcast RSS. In this step, we will fetch podcast RSS from given URL and store the episode list in Amazon S3 bucket. Then we create a custom vocabulary for Amazon Transcribe while still passing down the output from the previous function. Now this is where everything gets interesting. With AWS step functions, you can use choice to control the flow of your state machines. This particular step is vocabulary completed, accepts input from the previous function, and will decide the next step. If vocabulary for Amazon Transcribe is not completed yet, it will go to the left. Another interesting state in AWS step function is that you have the ability to give a waiting time. In this case, this function will wait for 5 seconds while still passing the output to the next function. Then, after it waits for 5 seconds, it will check again the vocabulary status and pass the result of the status back to its vocabulary completed step. Once vocabulary creation is completed, the next step is to create index mapping on Elasticsearch. Next step is for the state machine to process each podcast episode. If you can recall at the beginning, we have 2 state machines. The other state machine is to process episode. This step, process podcast episodes, is actually a Lambda task, which will call another AWS step functions state machine called episode state machine. So this is another pattern that you can use, a child workflow. It actually abstracts another workflow by calling another state machine through AWS Lambda function. Another pattern is similar to previous vocabulary checking. After we process an episode, it will check whether all episodes have already been processed or not. If there are still a few episodes that need to be processed, it will wait 30 seconds and return to process podcast episodes. The last step is to perform simple housekeeping, deleting custom vocabulary on Amazon Transcribe before it reaches terminal state, ending the workflow. Now we understand how this workflow works, along with a few patterns that we use in this specific state machine. Let's go back and perform the demo. We can also manually start the execution by clicking this button. Let's put something here as the execution name. I'm going to pass the input here, so our state machine understands the instruction. After that, we click Start Execution. Now it's being started. As it progresses, you can see that on the visual workflow, the box colors will change based on the legend shown. It's currently processing for custom vocabulary creation. Therefore, you see that the wait state is showing blue color as it's still in progress. Another feature in AWS step functions is you can run your workflow in any scale. We currently have one running here, so let's try to run another workflow. Okay, so we click on Start Execution, we give a name for this execution, and then we pass the variable again. And we click on Start Execution. Now we have another workflow running. This workflow ingests the data into Elasticsearch, so the user can perform a query against the output from Amazon Transcribe. This is my Kibana dashboard that I've prepared for this demo. Let's do a query. Previously, I performed step functions that only need to process 10 episodes. Here you can see that we have 10 hits in our Kibana. So let's try to search something in podcast title. I'm going to search for reInvent updates. We can also look into the details for each result. Our workflow with AWS Step Function transcribes the podcast feed, and it will also store the results here. We have various data points that we can use for further processing. For an example, we have transcribe field along with data location in our S3. And that's the end of this demo. I hope it helps you to understand how you can build your workflow using AWS Step Functions along with a few implementation patterns. The second pattern is monitoring asynchronous processing. There are cases when we need to wait for a job running asynchronously. And we need to wait and periodically check the status of a job to see if it's already completed or not. With AWS Step Functions, you can easily do this by combining few states. There is various types of state in AWS Step Functions, and two particular types for this situation is choice state and wait for state. By combining these two types, you can monitor asynchronous processing by making the workflow waiting for a specific time and then checking the status and finally make the decision. The third pattern is data availability at all stages. As you can see in the previous demo, there are cases which each stage needs to store its data. From raw data to processed data, it is a good practice to store the data in each location. For an example, the raw audio data of the podcast is being stored under the audio folder. Then, the vocabulary mapping for Amazon Transcribe is being stored under a specific folder. The last pattern is workflow abstractions. In the previous demo, we've mentioned about having two state machines. First is to process the podcast, the main state machine. The other is to process those episodes called episode state machine. Now, this state machine is actually a child workflow, abstracting all the operation from the parent workflow. To reduce the complexity of your workflow, abstract the complexity by using child workflow and include that workflow into the bigger workflow. All right, we've covered workflow patterns using AWS Step Functions and Amazon Transcribe. Now let's move on how we integrate workflow with Amazon SageMaker. There are some cases which we need to retrain our machine learning model as the data significantly changing over time. Say it for a week or so. In this case, it may be beneficial to frequently retrain and redeploy the model by using the most recent data, so the model is not biased by using older data. In the next demo, we'll try to answer this challenge by building a serverless pipeline to orchestrate continuous training and deployment for machine learning model with Amazon SageMaker. For this demo, the scenario is we are going to take housing prices. Housing prices in many areas are extremely volatile, so the distribution of housing price data for a day may be extremely different than the day before or even a week later. So the idea here is to periodically check our data stored in Amazon S3 using CloudWatch events to trigger the model training with Amazon SageMaker based on specific workflow using AWS Step Functions. Simply put, if there's new data, then retrain the model. You might think this as CI/CD for machine learning models. As CI/CD is to software, this can be continuous training and deployment for machine learning. With that being said, let's start this demo. Now we are in AWS Step Function dashboard. I've prepared one state machine for this workflow called SageMaker State Machine. So let's click on this state machine to see the details. We are going to walk through the workflow one by one. So let's see successful execution so we understand the entire workflow. This orchestration pipeline has a number of state machine steps. Let's review it all the way through to the end. The step machine is triggered by CloudWatch event. If the event meets the rule we've defined, it will trigger the state machine and call start check data function. Now, check data function checks the S3 bucket for new training data. It works by comparing the date of the last uploaded data file to the date of the most recent data file of a model that has been trained and deployed. Comparing the date is pulled from a system manager's parameter store. If there's no new data is found, then the state machine moves into no new data and reach terminal state, which is N. If new training data is found, then the data files in the training interval are added to a training manifest that is uploaded to S3, and the state machine moves into start training job step. Now let me show you how training manifest looks like. So this is a simple manifest. As you can see that we have the prefix along with those new data files. Moving on to the next function, start training job. Start training job function creates a training job in SageMaker for linear learner algorithm using training data specified in training manifest uploaded previously in check data step. If everything is okay, then the state machine will move into notify Slack to post a notification. If we set the notification, it will then post to Slack, but it can be anything, including sending an email or even other apps. The point here is we need to be notified once SageMaker starts a new training job. After posting notification, the state machine moves into notify Slack branch step. Notify Slack branch is a choice state. It looks at the stage of the pipeline and status of the training or deployment job via the input JSON to decide which step to move the state machine into. If it identifies from the model training or deployment is in progress, then it moves the state machine into the check status wait step. If it identifies that model training or deployment has failed, then it moves the state machine into the job failed or deployment failed step respectively. Finally, if it identifies that the model training job or model deployment has completed successfully, then it moves the state machine into job completed or deployment completed step. As mentioned, from notify Slack branch, if it identifies that model training or deployment is in progress, then it will move to check status wait. At check status wait, this function waits for 60 seconds before moving the state machine into get status step. Model training and deployment jobs can take some time to run. And this wait throttles the executions of the Lambda function in the get status task step to 1 per minute. After get status task is completed, state machines move into check status branch, which is a choice state. This function looks at the status of the training or deployment job via the input JSON to decide which step to move the state machine into. If it identifies that the training or deployment job is complete or has failed, it moves the state machine into the notify Slack step. If it identifies it's still in progress, it moves the state machine into the check status wait step to continue the loop. Now we're back into states after notify Slack branch. You can see that there's job completed function, which is a pass state. It doesn't do much, and why we need here? Because it is relatively easy to find that the training job has completed rather than digging into the input and output details. It will move into deploy model, which creates endpoint resources for the model and deploys train model to an endpoint. If the endpoint already exists, it is updated to use the newly trained model in a zero downtime fashion. If the endpoint doesn't already exist, a new one is created for it. It then moves state machine into notify select step and repeats back to the loop. Once the deployment is completed, the state deployment completed will turn into green. After deployment is completed, then it will update the parameters on parameter store to the date of latest training file that training job completed. This is to help check data step to challenge against this variable whether there's new data or not. And after it completes updating the parameter, it now reaches into end state. Now we understand the whole flow, let's head to the demo. What we are going to do now is to try to simulate the situation when we receive new training data. This notebook is prepared to generate and upload housing price data. Let's start with running the first cells. In the second cell, it will write CSV files and store them in this notebook. Here you can see that we've just generated a few CSV files stored in this notebook. Now we are going to generate JSON payload to simulate CloudWatch events. After that, we are going to put this JSON payload to start execution in step functions. Now we head to step functions and manually start the execution. So I'm going to click on this start execution button and pass in the JSON variable that I generated from the previous Jupyter notebook. I'm going to put an execution name here, and then I'm going to start the execution. And let's see what we have now. Yep, it's running now, and that's how you orchestrate machine learning pipelines using AWS step functions and Amazon SageMaker. So after we deploy an endpoint, where do we go from there? And that is a perfect question. After we successfully perform continuous training and deployment model with AWS step function and Amazon SageMaker, we can actually use it in our AWS Lambda function. And here is my AWS Lambda function. This AWS Lambda function will infer from our Amazon SageMaker model by invoking the endpoint. As you can see here, this code will infer from endpoint name that I've defined in environment variable. If everything works okay, it will return us the house price given the input that we will provide. So let's test this Lambda function. Here I already configured a test event, and this test event based on a set of attributes of home data. So let's head to the test button, and let's click the test button, and there you go. The model predicted the price is 22. Okay, so what to do from here? You can extend this AWS Lambda function to become API with Amazon API Gateway, or you can use it along with your other microservices. And that's all, everyone. We've covered orchestrating operational workflow, identifying few patterns, integrating the workflow with various AWS machine learning services, and also applying continuous machine learning training and deployment. Now, be awesome and build something. By the way, you can also visit the demo arena and watch how machine learning is used in real-life applications and get your questions answered by AWS experts. Also, please visit this link to learn more about machine learning on AWS. We also have training and certification available by AWS. Simply visit aws.training. Thank you again for attending, and really appreciate your feedback so that we can better understand the topics and services you would like to know more about. So please do take the time to fill out our survey and let us know what you think. Go build!